Observability turns model activity into security intelligence. In this module, we'll look at how prompts, responses, context, and behavior become telemetry for SOC workflows, supporting anomaly detection, incident response, drift monitoring, and compliance assurance for trustworthy enterprise AI. At this point, we've moved from understanding AI systems and shadow AI into governance, risk, secure architecture, and workload controls. Now we turn that foundation into operations: telemetry, logging, detection, investigation, response, and evidence that supports assurance. Traditional monitoring asks, is the system healthy? It tracks infrastructure, latency, errors, and alerts. Observability asks a broader question: is the system behaving appropriately? Because outputs are probabilistic and context dependent, teams need visibility into prompts, retrieved data, model responses, tool use, user intent, feedback, and policy outcomes. That broader chain helps investigate failures, detect misuse, manage drift, and demonstrate that the system is reliable, secure, and compliant. A useful way to think about AI observability is as a stack of signals, not a single log stream. At the input layer, capture who is asking, the session context, the prompt, and permissions. During processing, track model choice, retrieval results, tool calls, and agent plans. At output, evaluate the response, confidence, refusals, policy issues, and feedback. The control layer ties these signals together with guardrails, DLP, audits, rate limits, and incident triggers. Effective AI logging is about evidence with restraint. Capture the interaction: prompts, responses, system instructions, retrieved context, tool calls, and model version. Capture the operating context as well, including user or session identifiers, authorization, data sources, latency, token usage, and request metadata. Also record safety decisions such as guardrail results, blocks, overrides, refusals, and escalations. But treat logs as sensitive data. Redact, tokenize, encrypt, limit retention, restrict access, and make records tamper-evident. In LLM and RAG applications, the response is only one part of the evidence. Telemetry should follow the full interaction: the user prompt, security signals, retrieved documents, source systems, ranking scores, authorization checks, and final answer. That record helps investigators determine whether an injection attempt changed instructions, whether the model used permitted evidence, and whether the output leaked sensitive data, hallucinated, or violated policy. The goal is a traceable chain from request to response. Models are not static assets. Their behavior changes as data, users, policies, and business conditions change. Monitoring should compare today's inputs, embeddings, retrieval results, and responses against known baselines. The same applies to business signals such as task success, escalations, corrections, and acceptance rates. When hallucinations, toxic outputs, refusal failures, or policy violations rise beyond thresholds, the system should trigger review. The goal is early detection before quiet degradation becomes operational risk. Agents add another layer of risk because they are not just generating answers. They make plans, choose tools, call APIs, and may change real business systems. Observability has to follow that full chain: which user delegated authority, what context applied, which policy checks ran, and what outcome occurred. Strong controls watch for loops, unusual tool volume, escalation attempts, and unauthorized actions, then apply approvals, rate limits, kill switches, and audit trails. Telemetry only matters when it becomes detection logic the SOC can act on. For AI systems, that means mapping signals to threat scenarios such as prompt injection, data leakage, unauthorized retrieval, policy bypass, stolen credentials, and rogue agent behavior. Look for patterns, not isolated events. A strange instruction followed by sensitive retrieval and then a blocked output may tell a bigger story. Good AI detection connects context, severity, and response, so teams can move from logs to action. AI security becomes operational when its telemetry joins the SOC ecosystem. Prompts, model logs, policy decisions, and actions should be normalized into a common schema, then forwarded as high-value events to the SIEM. There, they can be correlated with identity, endpoint, network, cloud, API, DLP, and application logs. Detailed traces remain in secure observability tools. When risk is confirmed, SOAR playbooks can drive triage, containment, user notification, evidence collection, and escalation. AI incidents need dedicated response playbooks because the evidence is different. A prompt injection, data leak, unsafe output, or agent misuse may leave traces across prompts, retrieval results, tool calls, model versions, and guardrail decisions. Start by classifying the incident, then triage by business impact, data sensitivity, user risk, exploitability, and recurrence. Containment may mean blocking prompts, disabling tools, revoking access, rolling back models, or isolating data sources. Throughout the process, preserve immutable logs and traceable case records. Observability becomes durable when it is tied to governance, not left inside engineering alone. Product teams, model owners, data owners, security, risk, compliance, privacy, legal, and business leaders all need defined responsibilities. Governance forums turn telemetry into decisions, reviewing incidents, assessing model performance, verifying controls, approving changes, and documenting exceptions. The key is evidence. Monitoring data should support audits, risk acceptance, release gates, and continuous improvement across the full AI lifecycle. Effective AI monitoring is not one metric. It is a balanced set of signals showing whether controls work in practice. Security metrics catch attacks and leakage. Quality metrics track hallucinations, groundedness, and drift. Operational metrics reveal latency, failures, escalation, and containment speed. Governance metrics prove coverage, evidence, exceptions, and policy compliance. Together, these KPIs turn AI oversight from occasional review into continuous, measurable control management. Strong AI observability starts before launch. Define what must be monitored, which risks matter, and what evidence teams will need later. Then capture the right signals, prompts, outputs, retrieval sources, tool actions, and decisions, while protecting them with masking, encryption, minimization, and retention limits. At runtime, combine automated rules with human review to catch misuse, drift, policy violations, exposure, and control failures. Finally, automate audit evidence so compliance, investigations, and executive reporting are not rebuilt from scratch. The key message is simple. AI security must operate continuously. Observability gives visibility into prompts, outputs, context, behavior, agents, drift, and misuse. SOC integration turns those signals into detection and response. Governance connects teams, decisions, and evidence. Next, we'll apply this foundation to compliance, regulatory readiness, and assurance.